So the TFDF, it is abbreviation for Tangential Flow Depth Filtration. It is basically a very unique enabler platform that combines the tangential flow with the depth filtration. So we can handle high cell density, and at the same time, the product is transferred through the depth filtration. So this specific product is really a great match for all modality of gene therapy, AAV, lentivirus, adenovirus, from the growth, or it's actually capturing the integrated solution for upstream side, including the clarification that I like to integrate it and cluster it to the upstream side. So the TFDF, you connect it, is integrated into your bioreactor, and you can choose any bioreactor at your choice, and then you enable the cells to grow to higher cell density by using the TFDF at perfusion mode. So that's when you get higher cell density, you get more viral vector per the same amount of the same volume for the bioreactor. That means that you basically bring this process to the next generation manufacturing process, intensify the viral vector, and during the production, using the perfusion system to collect continuously your product that is secreted to the cells. If you don't have a secreted product like some of the AAV, you are doing lysis, and then you are using the TFDF in order to clarify the lysate. The added value on top of intensify the process and giving you a very high recovery during the clarification, it has a very significant low footprint, and that's a saving cost in GMP manufacturing suite, and also during the storage of this filter. You need 10 times less surface area for the depth filtration when you are using the TFDF for clarification. In addition to that, it's also a very rapid process. You can go up to 1,000 LMH. So basically, you reduce the time operator in the manufacturing processing the clarification step. And this is significantly important when you are working under stressful manufacturing condition. So I would say it is really an enabler into the gene therapy market manufacturing commercialization process.